Myself M. Bhavana. Today I am going to discuss about some problems regarding to computer networks. Let us see. First one. It is desired to send a sequence of computer screen images over an optical fiber. The screen is 3840 into 2160 pixels, each pixel being 24 bits. There are 60 screen images per second. What data rate is required? Here we have to calculate the data rate required. There are 3840 into 2160 pixels, which is gives rise to 82,94,400 pixels per frame. Each pixel needs 24 bits and there are 60 frames per second. We have to find out total bits per second, like 82,94,400 into 24 into 60, which is gives rise to 11.95 Gbps. This is the data rate needed to send the images over the fiber. And the second question goes to, television channels are 6 MHz wide. How many bits or seconds can be sent if 4-level digital signals are used? Assume a noiseless channel. For a noiseless channel using 4-level digital signals, here we find out by using Nyquist's theorem. Maximum bitrate is equals to 2 into bandwidth into log L base 2, and the bandwidth is equals to 6 MHz. So L is equals to 4. So log 4 base 2 is equals to 2. So bitrate is equals to 24 Mbps. And the third one, if a binary signal is sent over a 3 kHz channel whose signal to noise ratio is 20 dB, what is the maximum achievable data? Here we are using Shannon's theorem that defines the maximum data rate at which information can be transmitted over a communication channel with noise error free using advanced coding. Shannon capacity formula is C is equals to B into log 2 of 1 plus SNR. By substituting the values in formula, we get C is equals to 20 kbps. Fourth one, 10 signals each requiring 4000 Hz are multiplexed onto a single channel using FDM. What is the minimum bandwidth required for the multiplexer channel? Assume God bands are 400 Hz wide. The payload bandwidth is 10 into 4000, which is equals to 40,000 Hz. God bands are required 9 into 400 is equals to 3600 Hz, and the total is 40,000 plus 3600 is 43.6 kHz. Fifth one, why has the PCM sampling time been set to 125 milliseconds? By Nyquist's theorem, to avoid aliasing, sampling rate must be at the least twice the maximum frequency. For a 4 kHz signal, minimum sampling rate is 2 into 4000, which is equals to 8 kHz. Here, for voice 0 to 4 kHz, bandwidth is Nyquist rate is 8 kHz. Sampling period is equals to 1 by 8000 is 125 milliseconds. Hence, PCM sampling time is also 125 milliseconds. Sixth one, what signal to noise ratio is needed to put a T1 carrier on a 1 MHz line? Here we are using Shannon formula, that is C is equals to B into log 2 of 1 plus SNR. SNR is calculated as the ratio of average signal power to average noise power. So SNR is S by N. Here C is equals to 1544 Mbps and B is equals to 1 MHz. By substituting the values in formula, we get the SNR is equals to 2.8 dB. And the seventh one is, a cable TV system has 100 commercial channels, all of them alternating programs with advertising. Is this more likely TDM or like FDM? Cable TV systems use frequency division multiplexing. So each channel is given a separate frequency band. Hundreds of channels can be carried simultaneously as analog or digital signals. So the answer is frequency division multiplexing, FDM. And the final one, a cable company decides to provide internet access over cable in a neighborhood consisting of 5000 houses. The company uses a coaxial cable and spectrum allocation allow 100 Mbps downstream bandwidth per cable. Here we have to describe what the cable company needs to do provide this guarantee. The cable company uses shared bandwidth, so each house guaranteed 2 Mbps, that is total required bandwidth is 10 Gbps.